Hello, hello. The time is running. Okay. Okay, I've never done this. I've never probably given a talk in less than 12 minutes. We have like 25 minutes, I understand. There's two of us. So I thought it'd be important, like if you're at Google, that we talk a little bit about Google technology. But it's not supposed to be like sales pitch. I wanted to give you like an overview of Google's efforts in machine learning. Everybody's talking about it. And then I think the most interesting part for people who understand what machine learning is actually the second part. Wave your hand. So he will be joining me in a second and talking actually about using things like, who heard of TensorFlow? Okay. Who can describe to a 6-year-old what deep learning is? That's weird.
Does the 6-year-old have to understand?
Okay. All right.
Explaining is easy.
All right. So in two parts, so I'll look at the time, I'll speed through this. We have 50 slides in 25 minutes, so bear with me. I'll skip some stuff, I think. I brought a banana and apple for a short demo in a second, which you might find is pretty cool. Many people think Google's doing a good job, right, in terms of being a capable search engine. If you ask Googlers, or here, we have like 450 engineers here at Google. We think, we're not even halfway there. There's a lot of stuff that you can actually do. And so Google went deep into machine learning, deep learning, last couple of years, and I wanted to give you a little background on that. If you don't know what machine learning is, I won't go give you a 101 because I only have 12 minutes. But the popular imagination of what it is, right? You have I need a lot of data, and this is quite true, right? So data is the bottleneck in machine learning. It's better to have massive amount of data than complex algorithms. Throw a little math at it, and out comes magical results. Where in reality, it's as any data scientist will tell you, if they go into a project, 90% of the work is actually getting the data into one system, joining everything, etc. That's a lot of work, right? So you kind of have to ask good questions at first. You have to get the data. Before you have to interpret it. You have to understand it. Get in the subject matter experts. A lot of work involved, and this is actually where kind of cloud computing can help ease and automate a lot of these things before you can even create your first model, which you probably then have to redefine, and then you get magical results, maybe. So, anybody know what this curve is? It's one going up. So this is, does it say? So this is the amount of model files found in the Google directory, like projects where model files were discovered. So you see, so where machine learning was actually used in Google projects. So you see this rise in this case, starting to 2014, where we actually got rid of the previous version of TensorFlow, which was called Disbelief, and introduced TensorFlow internally because of some of the deficiencies that Disbelief had in terms of scalability and portability and these kind of things. And then 1.5 years later, we introduced it end of 2015 as a public version, but you see this rapid increase, and you see it in all kinds of applications, right? I love photos, right? So if I have to do the stupid calendar for the grandparents again, end of this year, it's very easy, right? I just say me and my son in 2008, I get all the pictures, right? It's pretty cool. I suited 2011, even though I can't see his face really quick, Google Photos shows me the image, and it even finds videos, right, of us just returning from vacation a couple of weeks ago. You see it in Google Translate, made a major jump since we started using deep learning. So this was, I think, September last year. And when you look at some of the language pairs, like French, English, you can see the deep learning, the yellow part that was recently introduced, and you can also see in the quality, is very close to what a human translation is. If anybody can tell me what the difference is between a human translation and a perfect translation, can speak now. Nobody? I don't know. We do research with a lot of little different topics, right? This is where image recognition helps. Anybody heard of this? I can't pronounce it, except the first word, but this is a very, there are a lot of people, millions of people affected of this worldwide. It's an eye disease diabetic people suffer from. It leads to blindness. It can be easily detected if you have a good doctor nearby. A lot of developing worlds, they don't have those doctors. So we actually took good doctors, showed them thousands of these images. They were labeled as healthy or where a disease was actually shown. And they're trying to build a model where maybe somebody who wants to get tested just has to look into some type of Philips apparatus and gets an immediate feedback in terms of, is this, are you at risk of getting this disease, and should you gather all the money from relatives and get that train to Mumbai and check out if you have any problems. AlphaGo, anybody heard of AlphaGo? I think it's one of the slides I'll skip now. What is machine learning trying to solve here?
Find the cat.
Huh?
Find the cat.
Find the cat? No.
No, it makes normal grass instead of this like blue red.
No, get rid of the stupid cat who shits on the lawn. Like, so you turn on the sprinkler system. So this is a blog post I found. It has nothing to do with TensorFlow or anything. I think you use something else, but everything starts out as a toy problem, right? You have something you play around, and then you need something later maybe to scale it. Anybody? You all know what deep learning is, so I'll kind of skip this. Just to save time. Anybody heard of this? I think I'll just show it. It's a very cool demo. What machine learning is, I thought deep learning is hopefully, oh, it works, okay. We're going to train a model. This is amazing. I think it came out like 2-3 days ago. Have anybody seen this? Oh, all right. So it's called, if you Google teachable machine in Google, you'll find it. So let's train a model. I haven't tested it like this, but let's train what a banana looks like. It's pretty cool. So it correlates to the cat here, and all it has, it's 99% sure it's even me in the picture is a cat, because there's only one class of it, right? So let's try training a second example, looking at the time. So getting an apple. So banana, apple, and what I also find it very cool. This is so fun to play with. So let's make this a cow. I thought this was pretty cool. Hold on, let's see if we can get this right. To turn on the sound. Let's do this, yeah. So bird. Let's train this. Bird? Oh. So, many things you can do. Hold on. That's not cool. So basically, like the images of the eye scan, right? You need a lot of examples of what is spam, what is not spam, and you can train these models. And I have some examples of customers actually doing this. So Google has a lot of services running on Google Cloud that have over 1 billion users, 7 of them. Google Cloud is actually the 8th service that just came around. So if you use Spotify or ran against trees playing Pokemon Go or tons of, you're one of these billion unique IPs where in the back end, or Snapchat, right, where in the back end everything is managed by by Google Cloud. So basically, Google Cloud is the external version of what Google actually uses internally, right? So have you heard of BigQuery? Which is the external version of an analytics data warehouse, where internally at Google, 80% of Googlers use something called Dremel, even though they don't maybe know they're using it, but they might be reading dashboards, which is fed by Dremel. So skipping some stuff. So networking infrastructure, that's one part. We just opened a region in Frankfurt, by the way, if you didn't hear that. So if you legally need your data to be locally here, you can actually do that now. And then a couple of white papers that Google released in terms of MapReduce that you might have heard. Things like BigQuery that I just mentioned, or the Dremel white paper, the Bigtable white paper. So basically in the middle you see all these white papers and when Google published them and some of the open source efforts. You also see Google being more involved in these open source efforts with things like Apache Beam or TensorFlow. And lastly, on the bottom, you see managed services. So this is like where BigQuery is a good example of a serverless analytics warehouse where you don't have any machines, everything auto-scales, and I can do a query with SQL. I've done it in demos with across petabyte of data, right? And you can get answers in seconds and minutes, where typically you probably would have to wait hours or days, actually. And this is true for data processing, if you need a NoSQL type database, or machine learning that I'll talk about in a second as well. So you remember this picture, right? So there's all these steps necessary and actually what you need to do and in order to actually get the data, do some pre-processing, feature engineering, etc. So a full life cycle could look something like this, where you have inputs. You can use cloud services like Apache Beam that can run on Google Cloud Infrastructure, or you can use Hadoop, the Spark technology. Configure a cluster, Spark Hadoop cluster, configure how big the cluster should be, click a button, wait 90 seconds, and run your PySpark jobs, for example. But then comes to all the world of tuning models, etc. So this is actually the product which is the managed version of TensorFlow. So this is called Cloud ML or ML Engine, which is basically saying using kind of serverless environment, using Google infrastructure to train and serve their models. So what you can actually do is, you got your trained model, you can you played around with it on your laptop or your local GPU cluster, but now you want to go in production and not do this training on thousands of images, for example, but on billions of images. And this is where actually cloud can actually make life a lot simpler. Then you have your models, and then you deploy your models. And then, so ML Engine is basically, in this case, also a scalable service for serving billions of queries, predictions, etc. Anybody heard of TPUs? All right. So those will be made available more and more for customers in the future. But basically, Google figured out if everybody in the world with an Android phone uses speech recognition for 2-3 minutes a day, we would need to double the sizes of double our data centers, basically. And these TPUs kind of allow us, which is our own hardware for accelerating training and serving models. So this kind of counteracts this movement, and this will be available for customers to access as well. And researchers can actually access this cluster today if they sign up for it. So what Google offers in terms of models is pre-trained models, right? Vision API, like I showed with photos. You can upload photos, get back how many people are in the photo, are they smiling or not, and the same is available for video, which is not on there. Translation, speech recognition, so basically all the consumer kind of APIs that or services are available as an API. On one side, the pre-trained models, on the other side, roll your own model. And I have a couple of examples, and now I'm going in your time slot, 1 second. So I'll run through this. So this is Airbus. I thought very fitting for our next example as well. They're selling satellite images, and as you can, the customers who buy these satellite images, they want the snow in them, but not the clouds. As you can clearly see the clouds here in this image up here. You can see that it's probably not that easy, but they actually use TensorFlow and the managed service to train a model where now the model can identify where's clouds, so they know that they would need to exchange that image with a different image in the timeline. Examples of TensorFlow and counting trucks. This is pretty cool as well, and this is my last example. This is a monitoring. So this is an NGO monitoring illegal fishing. Every fifth fish that is caught worldwide is illegally fished. So you can actually skip this, but you can actually identify movements of ships and what kind of fishing ships they are, if they're in the wrong place at the wrong time, and they're using this technology actually to identify these type of movements and you know, get assigned fees, I don't know what you call it in English, like Bußgeld? Fines against these countries who actually do this. And with this, I go to Joe.
Yep. Thanks. Thanks, Arthur.
Yeah, you just click next, right?
Yeah, yeah. So I represent the company BuildingRadar, and we are a knowledge base for, I don't know, can you guys hear me or do I need to use the mic? Is it okay? Okay, with the mic it's better. So we are a knowledge base of global construction projects. We collect knowledge from different sources and we structure them so that our customers can really search using our custom search engine and find sales and construction leads. And right now I'm going to talk about building your own model, something which Alex briefly touched upon. And as I told you that we have different sources of information that we parse, and one of them are tender documents, which is nothing but an official description of a building. A human reading these tender documents can easily understand if this is a tender document for a new hospital construction, or is it a new tender document for a school or something like that. But for us, this business model will not work out, and it's pretty resource consuming because you really have to have someone reading through the documents. So we move to training models and categorizing them automatically. We will talk about this classification task, but let's understand what it is from a very high-level perspective. So we just give it a function of inputs, which in our case are the tender documents. And then in terms of deep learning or the models that we are going to be using, it can translate to a decision function over equation over the input. And as you can see, the only thing that the model learns from this is the variable to represent this equation, and it looks at all the data points or observations and really sums up or gets an average approximation of the variable. And that's about it. So one of the models that we quite recently used and had success with is convolutional neural net for this. There are different layers in a convolutional net, but let's look at an overview. What basically it does from the point of view of a high-level perspective is the convolutional layers extract features for you. And in terms of, let's say this is a tender document for a hospital, it extracts the features like operation theater, beds, emergency, and then you can use these inputs to the classification layer, and the classification layer gives you the probability of which class it belongs to. That's the high-level overview, and in theory it looks like this. So we have first the input layer, which is the layer for our documents to come in, and then we have convolutional layers and polling layers. And by the way, the polling layer actually does a downsampling, or it reduces the dimensionality. And then we have multiple of them to really extract meaningful features. and the fully connected layer and the output layer forms together the classification layer for us. That looks a bit complicated on the first view, or you have to put in a lot of effort to build that. But in reality, if you use something which is pretty standard machine learning framework, then you can just call different functions and be done with it. Like you can see for the convolutional layers, you just call cont2d and functions like that. The only two new things in the slide is the loss function and the optimizer function. What the loss function really does is calculates difference between the predicted outcome of your net and the actual outcome, and then fits this back into the optimizer function so that it can really go inside and tune the variables so it can do better classification. And that's it, and then you're done and you start training, but you also need a way to visualize different matrices of training, as what's the accuracy and stuff like that. What's really good about TensorFlow is that you have a TensorBoard to visualize. How many of us here have used TensorBoard before? Quite a lot of us, nice. So we can really visualize the learning progress, and also in terms of complicated networks, we can go into the graph and really see how the connections look like. And it's super easy to set up. But for us, we actually have multiple different configurations of networks running, and we needed to have multiple experiments stored and structured in some way. So we moved away from TensorBoard, and we have a central database wherein at the beginning of each training session we store the configuration and also the learning matrices, and that gives us a nice overview over our experiments, and then you can connect dashboards to it and see your overall progress, which is really nice. So that takes care of running multiple experiments, but still when you want to train a model, you really have to take your training application, do some configuration, and then start training it. So in terms of portability, we moved to standard containerizing engines like Docker, and we bundled our training applications on top of this container so that we can really go in and deploy on one of the servers and start training. Now, some of us know that this is really easy to do on CPU, but on a GPU level, this is complicated. But the good thing is NVIDIA actually came out with NVIDIA Docker wrapper, which is a nice, simple wrapper around conventional Docker, which really encapsulates the GPUs and the host driver, so you can write your training apps on top, and then forget about the underlying layers, so you can just compact them and